Alright, it's been nearly forever since I got to work on the ball joint mod. I say got to, by that I mean, you know, finally got off my lazy ass to do it. Anyway, I've got a problem here with this hitting. Now this is the side I'm working on that's going to be for the lowered vehicles. So it's going to be up in this angle here anyway, but I really don't want that hitting there. So what I'm going to do is I'm going to cut the spot welds, I'm going to re-angle it, tack it back on. I'll figure out that angle later for the tubing cutting. And hopefully, you know, I'll test fit these pieces again on the other side. I'll double check everything. And hopefully I can use those same angles on the other side. Just change the plate just a slight bit. And that way, you know, the bushing tubes and the arm tubes here can both be the same. Just have to change the plate. Alright, that's loose. I already have the welder already turned on and everything, so just gotta get that out of the way just a little bit there. Yes, I could probably close my eyes and do the tack welding and that stuff, but the challenge is there. You close your eyes, you don't get to see or watch what you're doing. Hopefully this will come over here without smacking on the camera too bad. Alright, I got some clearance there. Alright, doesn't look like it changed the angle more than a degree or two, so that shouldn't be a problem later, but we'll get worried about later. Alright, I've got it setting up basically more ride height. Been so long since I've been out here trying to remember. It seemed to me that with the shock in the middle of its travel range, that was going to be just right with the lowered setup. So I've got my digital level out again. And what I'm doing here is because, you know, this thing's sitting on air, pneumatic tires, all that kind of stuff, I need to set the alternate level 0 in here. Okay, so I'm going to tilt this thing back a little bit to get it fairly level that direction. I've been, well, let's just shut it off and turn it back on and see what we get here. Alright, about 0.7, 0.8. Press the Alt 0. And that now says that whatever this frame is sitting at is 0. So when I go to compare it to my spindle over here, I've got about 0.2 degrees negative camber, which is perfect. I've got some shims in there, washers in there, stuff like that. I can easily come back out. I'm really not going to worry about it too much. And also check it against that. It's they seem to vary a little bit, but I'm still easily within a degree, half a degree, that kind of thing. Now the other thing is here, I was just leaving that, and then it dawned on me that the front to rear level is not the same either. So I'm going to level it on the frame horn, which is for the core support here, or the fenders and that kind of thing, because the frame's got a rise and fall basically. These are not at the same plane as these. So without going and checking the book and all that kind of stuff, I'm guessing that these should be level. Okay, and you can tell by the bends right here. This is flat right here. This has got a dimple, so this is bent back. I'm going to assume this is flat for the body. This is at an angle because of the frame. It's all pretty close anyway. So let's set the Alt 0 there. And it's, let's see here, that frame's got a 3.5 degree tilt to it. So my shock tower is right on the money. So I like that better. Anyway, what I'm going to do here is I'm going to carefully come in here off the flat bolt surface. And I've got right about 3.8 to 4 degrees, which is right in the target range where I'm looking. The other side had a little bit more. Part of it is like on the other side, I was trying to keep it exactly in the center where it was before. On this side, I don't really have a reference for that. So this tire position may be forward a quarter inch or so. Probably not even enough to be noticeable. Anyway, and if you notice here, as long as I'm here, let's see if we can... Alright, if you see that, hopefully it focuses on it. I took the bandsaw and I took basically 2 or 3 blade width cut in here. The reason I did that is so that when I clamp this with the vice grips, it'll squish down and squeeze on the 3/8 inch plate here. That way I can hold it in place and still be able to quickly loosen that, move it, tweak it, that kind of stuff. So I like my dimensions, my measurements, where I'm at right now. I'm going to go ahead and put a couple of nice tack welds in here to hold this, and then I can run it through its range of motion. Alright, let's throw a couple of tack welds on here. Upgraded this umbilical, this gun on my MIG welder to 15 feet, and man, it's so much nicer. Well, that should certainly hold well enough for a range of motion check, so let's see. I could probably just go ahead and leave those on there. It moved a little on me there. I'll have to double check that later. So, all the way up. And that basically would be the shock bottoming out in there somewhere. We've still got 3/4 of an inch, an inch down there for the bump stop. And bottoms out there too. So it looks like it's right in the sweet spot for the ball joint. So basically the whole point of checking all this was to see, you know, on the other side with the stock ride height, I have to have that plate bent. I have to have it at quite an angle to stay within the range of motion on the ball joint. On this side here, I don't have to. So I'll tell you what, let's take this out for a second and see. Alright, we're hitting down here on the frame. So we still have room on the ball joint. Now that is the ball joint running out of space there, running out of travel. We've still got clearance on the frame there, so with the arm. So as you can see, I've got a good, well, maybe, I don't remember if I zoomed it in that far. There's about 3/4 of an inch here, okay, at the shock. That would actually, equates to more travel than that. So let's see how far we have to lift it up here. Oh yeah, got it. Oh, even a little more. Yeah, so we came up at least an inch out here. That's perfect. That's going to make that fairly easy. Basically now I can take this off. I have the arm angles to the tubes, and I can more or less start tracing and figuring out my plate size there. And since the first set out the door will be for a lowered truck, that's basically what I need to finish first. So in fact, I think the first 2 sets out the door. Anyway, I'm sure this segment of video is plenty long enough. So, all right, so I took it off the frame. Like I said, these pulled in just a little bit, 1/16 of an inch on each side, basically, which is fine. You know, in the final compensation, it just simply means these angles stay the same and everything, and it'll just come out a little bit. I plan on leaving enough metal around the sides and that stuff that shouldn't be an issue. So anyway, let's get an idea where the arms are at here. Now I'd love to figure out a way to be able to put the drawing on the scanner, get it into the CAD program, and then even if I have to, you know, trace the lines over it, stuff like that, and then size everything according to the dimensions. I don't know how to do that, so maybe Red Eye will clue me in if that's possible. Okay, so the length of these arms and that stuff will change just a little bit and stuff, so basically I want to trace out what I've got in case stuff moves or whatever. I can, you know, kind of come back in and put it where I need it. Now, the other thing too is what I'm going to do is as I start to draw this in CAD and that stuff, I'll basically, with the limited knowledge I have with CAD, I'll try to get the plate close. I'll make a print. I'll lay this down over it, or I'll lay the print over this, look at it through the light basically, and see how close it comes to matching up. Crude, but you know, that works. And so, you know, kind of what I'm shooting for here is we'll swing out a little bit here and we'll leave some space on the arm there. I might shorten this arm just a little bit here, but some of that stuff can get changed without any problem later, so I don't want to leave too much hanging out here because I noticed clearance on the shockwise and that stuff. I need that that little tip right there to go away. Okay, so now we'll come out about a 1/4 inch. Now that's all overkill, so I don't need to, you know, that tube can actually stop right about there. Well, let's see if this tube comes out and I shorten it up a hair here. We want roughly about the same engagement. All right, so we'll call that good because that's about what we got there, about what we got there. So I'll bring that around and then go ahead and roll that forward and keep it round, just for cosmetics sake, I guess. So I'll compare this to the other CAD thing I have. It's not too far off. Okay, just rambling for now. Blah, blah, blah. Alright, that's what I got traced out so far. So basically what I'll do now is cut the pattern out, transfer it over to a piece of, oh, that's only 1/4 inch. I'll transfer it over to a piece of 3/8, go ahead and cut it out. That way I can prove the concept and I like it and everything like that before I go spending several hours on the CAD with it. So that's where it's at for now. Yeah, let's just clean up enough area here for the template now that it's cut out. Certainly close enough. And it blew away where? There we go. Alright, now one thing I want to do. Well, to get those holes there so I can mark them, I either have to hold it in place or if I poke a hole through the paper, alright, we'll see if this works. Okay, now that I have holes there, I can basically just put the Sharpie, little, you know, just dab it in there. Should give me a mark there. So hopefully I can do this without moving the rest of it. How about that? So I'm going to draw a circle around each one of those so that with dust and crap like that I won't lose it. And I'm actually going to punch them now while I'm thinking about it. And then I'll get to doing some drilling and cutting. Same thing I've shown before. Now there's probably not too many people that watch all of them, so I'll just do some of this stuff again. Now this is a snap punch. I think that's the proper term for it. There is a spring-loaded mechanism and an anvil inside that pushes it up and releases, and the spring slams the anvil down. And it just makes a fairly light mark, okay? But you can come back and find it with a point. To leave a mark big enough for a drill to find, I'm using a regular center punch to give it a little bit more pronunciation. So that way the drill can find that a lot easier. Got to cut a hole saw there, drill 4 holes, and start cutting it. Alright, this is probably going to get pretty loud. I'm going to knock at least a lot of this out with the cutoff wheel here. 7-inch cutoff wheel, Harbor Freight cheapie, but gets the job done pretty lickety split. Exact same technique and everything like that if you use a 4.5-inch or a 4-inch. Might just go a little bit slower. Surface, if they're running the same RPM, the surface feed out here is a whole lot faster on a 7-inch than a 4-inch. So I'll do some cutting. Don't know if I'll show it all, but at least some of it. Whew. I think I'll open the door here. Oh man. Got the smoky in here real quick. You can hear those bearings, but there really isn't any way to get in and grease them. I could take it apart and do it, but sheesh. When I cut that burr off the backside, I'm not putting a great deal of pressure on there. So, I just need to cut anywhere in there to, you know, get that cut off. I could actually just put it in the bandsaw and take a nice slice. That would, that'd be a lot more comfortable than cutting that off with the cutoff wheel. I'm not done with the cutoff wheel, but I think the bandsaw will make that cut nicer. More easy on me. Now that piece of steel is 7 inches. This is a 7x12 bandsaw. We'll see if it clears. And I'm guessing it's going to be pretty damn loud. Yeah, you know, let's do this. Let's do this instead. It'll make a nicer, more accurate cut, but I can tell you that cutting that 3/8 on the edge like that will just scream, especially the part well above the and I'm pretty damn close there. Get it tightened up. Is that right? some of that jumping is from the seam in the blade. A little bit of it too is the fact that the teeth way up at the front there, those cut, they fill up as a chip, you know, so then they're traveling all the way down loaded. You know, so it builds up and it jumps a little bit because you know, they build up and they bounce, they clear. You know, cutting it on the edge keeps the blade a whole lot cleaner, cuts a ton faster. But this is a much more accurate cut. And I don't know that the overall time is much faster. But at least this doesn't make near as much noise. Alright, I need to just take the burr off here. I was doing something else earlier and put a different belt on here, so I'll just go ahead and change out the belt. These belts, they're cheaper belts, I'm guessing. They are directional. But it's still pretty easy to change. So, because of this thing, I did turn the speed down just a little bit. The torque of the motor was slipping and spinning in here so bad it was walking this other belt off. But this should work. Yeah, you can hear it's a little slower than usual. I'll do a little more cutting here. Went ahead and pulled out the Ryobi 4.5 inch. We'll see how fast it cuts compared to the other one. The bearings are much quieter. And it's not really so much the bearings, it's the beveled gear in there. This thing drives one beveled gear onto another, and they're just cast gears. They're not machine precision or anything, so they're pretty sloppy, but anyway. Wow. That ate up a chunk of that. But makes a pretty darn nice line there. Certainly good enough for prototyping, far nicer than a plasma cutter would leave. really like the trigger pull on the Ryobi, but that does get kind of hard. You can lock it when you squeeze it in. But I'm going to have to change the cutter wheel there, and the rest of the cutting is the same. So I'm not going to subject you to that.